Okay, hello, let's go ahead and get through lesson 1.6. I'm going to make this video on multiplication and division of real numbers. Now, the ways to show multiplication, if you're not already familiar with this, is, a lot of times in algebra, we don't necessarily show division with the typical X, like you normally have seen it all your life. But in algebra, there's a few different ways. We try to avoid using X to represent multiplication because X is typically a variable in an algebra problem. So there's a lot of different ways you can show it. You can use a little dot, you can show it doing this like you want to show 9 times -7, something like that. And sometimes a negative, not to throw you off, but a negative will sometimes be in parentheses, or it may not. It doesn't necessarily have to be, but a lot of times it'll be that way. Because it can be written like this. But I just think sometimes the parentheses are added just to make the negative stand out a bit more. Okay, but that's called the binary symbol right there, that little dot that represents multiplication. We can show multiplication where we don't even use a dot. We can just show the number in parentheses right up against the 9, the 9, and then there's no symbol other than the fact that it's right up against the parentheses, and then times -7, just like that. And I haven't been answering these, but by the way, this is -63. What else can we show multiplication? Well, you know what? Another way is that both of them could be in parentheses. Like sometimes you'll see it like this. You have 9 times -7, like that. It could be expressed that way. And what else? I think that's pretty much it. I mean, this is more a computer type thing, but especially if you guys are putting stuff in the computer, your asterisk sign, that asterisk, if you guys put an asterisk in, your computer recognizes that as a multiplication symbol, not the X, which is kind of weird. But if you use the asterisk, which I think is like you have to shift 8, looks like on the keyboard, it's shift 8, and you can do that. But like I said, that's more of a computer type thing, not really something you'll see on paper. And then here, let's go through the rules of multiplying real numbers. So the rules are this. Now, here's the thing. I'm going to mostly kind of focus on when I talk about the rules, I'm going to focus on multiplication. But the rules for multiplication and division are the same. Obviously, they're not the same operation, but they do share the same general rules. Another thing, too, to kind of keep in mind when you're multiplying and dividing positive and negative, sign numbers in general, is that, the rules that you learn for addition and subtraction are completely different than they are for a multiplication division. Like an absolute value, like who wins, who's the bigger number, that really has nothing to do with it. It has no bearing on whether the answer is positive or negative. What does matter are the signs. So when we look at multiplication, let's just go through some general rules here. One rule is that you multiply a positive. This is something you've already known. A positive times a positive will equal a positive, right? We've known that all our lives. Positive times a positive. All right, then another rule is a positive times a negative. And a negative times a positive. Okay, so whether it's positive times a negative or negative times a positive, and switch in their division if you want, it doesn't matter. But the rule for that is that is going to be, in both cases there, that's going to be negative. And then the fourth rule is that when you have a negative multiplied or divided by a negative, that is going to be positive. always. It doesn't matter if it's -1 billion times -1 billion, right? Both are pretty huge, you know, relatively speaking, negative numbers. But yeah, -1 billion times -1 billion is going to come out positive, no matter how you look at it. Now, also keep in mind that these rules that I'm talking about here, they involve two numbers, right? They involve multiplying positive times positive. You know, we're multiplying two things. Now, it's you have to keep in mind that not all the time are you multiplying just two things. Sometimes you're multiplying a string of 3 numbers, 4 numbers, 5 numbers. But a general rule that you want to follow is just kind of just work it out from left to right. Just you can only multiply in your head mentally 2 numbers at any one time. So just go left to right and keep working it out from left to right, and follow those rules: positive times positive, positive times negative, etc. And you know what they are. Another thing too to kind of point out is that some people notice this, that when the signs are the same, you know, when the signs are the same here, you know, when you're multiplying or dividing a positive times a positive or a negative times a negative, notice how it's positive, you know. And when the signs are different, positive times a negative or a negative times a positive, that is going to be negative. That's going to be negative. So that's another, I mean, if you think about it, there's really only 2 rules. Same signs is going to be positive. Different signs is going to be negative. All right, so let's just work some of these out here. We've got, for number 1, we've got a negative times a positive. Negative times, well, that's going to be negative. So it's going to be -12. You see, as for the arithmetic, the multiplication is still the same. All right. This one we're doing a positive times a negative, so that is going to be negative. And you can think of this as over 1 if you want to think of that as a fraction. And you get -50 over 5, which eventually simplifies to -10 over 1. And -10 over 1 just as well be -10. All right, now 0 is unsigned. Now that's neither negative nor positive, right? So it's neither negative or positive. So 0 is just 0. So the rule for 0 is that it's always 0. There's no such thing as -0. There's no such thing as positive 0. 0 is just 0. All right, for number 4, we have a negative times a negative, which makes a positive. You don't have to put a plus sign if it's positive, but that's positive. And then 9 times 12 is 108. 108. There you go. For number 5, we've got a negative times a positive. That's going to be negative. And then 2.5 times 10 is 25. The decimal basically just moved over 1 place to the right. All right, moving along here, number 6. Number 6, why don't we do a little cross canceling just to make things more interesting. 4 and 10 both can be divided by 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. And then 9 and 15 can be divided by 3. So 9 divided by 3 is 3. I'm going to just put this negative up there. And then 15 divided by 3 is 5. And now we have the numbers that we need. So we should get, we're all done with this, -3 times 2 is negative, oops, sorry, just missed something. Yeah, I'm going to put that, I should put that negative right there, but a negative times a negative is positive. So this is going to come out positive. And then this is going to be 6 over 25. 5 times 5 is 25. For number 7, let's go ahead and make all these into fractions. And then look for any cross canceling we can possibly do. And I see a little bit of cross canceling right here with the 6 and the 24. And 6 divided by itself is 1. And 24 divided by 6 is going to be -4. And I'm just kind of putting that negative up there. So it's -4. And now notice all the denominators are 1. So we really don't need to worry about the denominators. We just know that it's going to come out to be an integer when we're all done. And then here, let me just rewrite the problem. So we have -5 times -1 times -4. Okay, so that's what we have there. I mean, we have a 1 in the denominator, but we can kind of just disregard that. We don't really need it. So when we do this, just go left to right. A negative times a negative times a negative is positive. So -5 times -1 is +5. I'm going to drop down times -4. And then right here, we have a positive times a negative, and that's -20. That's all right. Do some cross canceling on number 8 as well. And if you have the same exact number diagonal, just turn them into 1s like that. We do the same thing with these 4s. And in terms of cross canceling, that's as much as we can do. So let's just go ahead and multiply left to right. 1 times 1 times 1. Well, that's not too hard. That's 1. And then 1 times 1 times 5 is 5. So you got 1/5 right there. All right, exponents or exponential expressions. Let's just go right through this here. What I'm going to do is, yeah, your notes don't give a ton of room here for this. I'm going to add a page and just kind of talk about this. Now, let's just go through some of these. Now, there's a general rule that you need to follow with exponents and negatives, especially because I'm going to focus on negatives here. And it's when there are parentheses and when there are no parentheses. Okay, so you have, let's just kind of talk about with parentheses first. So you have, oh, let's do that. All right, so with parentheses, what you're going to do is, let's say let's start off pretty simple. We have like -3 squared. Okay, now what that means when you have with parentheses, notice the base is completely enclosed in parentheses, -3, and that's being squared. You're going to do -3. What that means is -3 times -3. You know, and so that means a negative times a negative, which is positive. So that comes out to be +9. All right, I'm going to keep kind of going down the line here. -3 to the third power, what that means is -3 multiplied repeatedly 3 times. So -3, use a dottish. Do that since we just talked about it. So -3 times -3 times -3. All right, and so in this case, we have a negative times a negative times a negative, which is positive. That's +9. And then drop down the times -3. And then right there, we have a positive times a negative, which is -27. Right? And let's keep going here. Let's see, we do -3 to the fourth power. Now notice every one of these examples so far has the base in parentheses. We have -3 in parentheses. We have the exponent outside the parentheses. And just expanding that out, that means -3 times -3 times -3 times -3. And let's make a little notice. Let's kind of notice something here. Notice you've got pairs of negatives. We have 2 pairs of negatives. We have negative times a negative. Now we know, I'm not even working on the arithmetic here. I'm just looking at, the sign. A negative times a negative is positive. Well, so will these. That will also be positive. So you have a negative times a negative and negative times a negative, which is positive. And so you end up getting, when we're all done with this, 3 times 3 times 3 times 3 times, that's 81. So it's +81. Okay, and so the rule is, let me just do one more for good luck, why not? -3 to the fifth power. That means -3 times -3 times -3, 5 times over. So that's what's going on that problem right there. And you've got, with this one, we have 5 negatives. So if I look at it and if I pair up those negatives again, you got a negative times a negative right there, that's positive. These two negatives make a positive, but this negative is kind of just left over, and it has nothing to pair up with, meaning it's not going to pair up with anything to make another positive. So when this is all done, and when we're finished and done with this, we're going to end up getting a negative. It's going to be negative what? It's going to be negative 243. And the thing I want you guys to notice here is that look at the power. Look at the exponents. We've got 2, we've got 3, we've got 4, we've got 5. Now, if we group those into even or odd powers, you'll notice something. That when it was even, 2 is even and 4 is even. Notice when it was even, it came out to be positive, right? In both these cases, it came out to be positive. When it was odd, in both of these cases, it came out to be negative. And that will always be true. That will always be true. So if you have, like, we don't have to actually work this out, but let's say we have negative 2 to the, 41st power. Negative 2 times negative 2, which is it's actually a really huge number, or in terms of the absolute value, it's going to be pretty big. But it's negative 2 times itself 41 times. Not negative 2 times 41, that's different. That's 82 or negative 82. But it's negative 2 times negative 2 times negative 2 times negative 2. And I'm not going to say all 41 times, but that's what's going on there. All right, but if we're just paying attention to the fact that this is odd, that's odd, well, I know that this is going to be negative. It's going to be negative something. Some number. I'm not going to really worry about what the number is. What I want to just kind of focus on here is the fact that it is negative. Like right here, we have, let's say we have negative 10 as our base, and we have 30 as our power. Well, that's odd, or not, that's odd. That's even, I mean. That's even, and that is going to be positive. That's going to come out positive. Actually, that's going to be a 1 followed by 30 zeros. So you can write it out if you want. I'm not going to do that, but it's a pretty big number. All right. So with parentheses, that's kind of the focus here. With parentheses, the rules have to do a lot, or not a lot, completely, 100%. They have to do with the power. They have to do with whether the power is even or whether the power is odd. Okay, and if it's even, it's going to always come out positive. If it's odd, it's always going to come out negative. But that's with parentheses. With parentheses. Here, while I'm thinking of it, I don't want to forget this. Negative. Let's talk about negative 1 really quick, because that's a lot of times people confuse that. Negative 1. Let's do negative 1 to like the 9th power. Well, that does not mean negative 9, nor does it mean positive 9. It means negative 1 times negative 1 times negative 1 times negative 1 times negative 1, 9 times. I think I did it. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. And just kind of showing in this here. Well, that's positive, right? That pair is positive. That pair is positive. That pair is positive, and this one's left over. All right, but it's not 9. It's not negative 9. It's just going to be negative 1, because 1 times 1 times 1 times 1 is 1. Multiply that by 1, you still get 1 again. Multiply that by 1 100 more times, you're still going to have 1. No matter how many ones you multiply, you're always going to have 1. Okay. So if you have, let's say we have negative 1 to the 426 power, something like that. Well, don't need to write it out 426 times. That would be wasteful of your time, but we know it's going to be positive 1. You don't have to put a plus sign there if it's positive. I'm just kind of exemplifying the fact that it is positive. All right, I'm going to add another page here. Sorry. Another page of these notes. All right, and then when you have no parentheses, let's talk about that. And this is with, again, this is with a negative base. So we're focusing mostly on parentheses with a negative base, either parentheses or no parentheses. And when you have negative, let's say we do the same number. Well, let's do a different number. Let's do -2. So we have -2 to the first power. Well, anything to the first power, anything to the first power equals itself. All right, so -2. All right, -2 squared, no parentheses again. And if that did have parentheses, it'd be different. But since there's no parentheses on this one, it's going to be -4. All right, we have -2. What did I write? -3. -2 to the third power. That's what I meant to write, the 3 there. That is going to be -8. -8. And you can probably see a pattern emerging here. -2 to the fourth power. That is going to be -16. -2 to the fifth power is going to be -32, and so on and so forth. So the point that I'm trying to make here, and hopefully that it's getting across to you, is that if the base is not enclosed in parentheses, but it is negative, it's always negative. It's always negative. So it doesn't matter if it's even or odd. That matters when there are parentheses, but when there's no parentheses, it doesn't matter. Because that negative is basically kind of floating out there in a way, in a sense, it's floating out there, and it's not being affected by the repeated multiplication. So, if I were to kind of expand -2 to the fifth power, what that means is -2 times 2 times 2 times 2 times 2. That's what that means. So that negative is just kind of floating there. It's not really affected by the repeated multiplication. So that negative is going to stick on the answer. It doesn't have another negative to cancel itself off with. Another negative would make it positive, right? Multiplication wise. But a negative just there is going to make the whole answer negative. All right, so that was quite a bit of a detour there. Let's go ahead and get to this. So now we should be able to do these. Okay, so number 9 and number 10, they both have parentheses, so we're going to pay attention to whether it's even or odd as an exponent. So that's odd, and odd tells you it's going to be negative. So 3 times 3 times 3 is 9. No, it's not. 3 times 3 times 3 is 27. So it's going to be -27. So -27 right here. Now right here, this is even. So that tells us it's going to be positive. So 12 times 12 is 144. All right, now this one has no parentheses. This one has no parentheses, therefore it's always negative. So it's going to be -64. 4 times 4 times 4. Because 4 times 4 is 16. And then 16 times 4 is 64, right there. All right, number 12, we have parentheses and we have an even power. So we're going to pay attention to the fact that it's even, therefore it's +81. 9 times 9 is 81. Right here, we have an odd power, and the base is enclosed in parentheses, therefore it's going to be negative. So we're going to do, we're essentially just doing 1/5 times 1/5 times 1/5. 1 times 1 times 1 is going to be 1. I'm just going to stick the negative up in the numerator. And then 5 times 5 times 5 is 125. And remember, there's a few different ways you can express a negative ratio or fraction. You can kind of put it right in the middle. I think I've talked about this. Or you can have it in the denominator. all three of those are, I think, acceptable ways to express a negative fraction. But yeah, it can't be like, you can't say, well, it's negative here and there. That's different. That makes it a positive. All right, so you can only put the negative in one place when you're expressing a negative fraction. And then for number 14, we have -3 to the third power. -3, well, no parentheses on this one, so we know it's negative. So it's going to be -27. -27. And the rules for dividing, those are all the same, but it's kind of worth just making sure we know how to do these. So for number 15, this is a negative divided by a positive. Well, that is going to be negative. So it's going to be -3. Right here, we have a negative divided by negative. That is positive. That is positive there. So let's go ahead and solve this the way we do with all fraction problems. We got to flip the second fraction. Keep, change, flip, right? You're going to keep the first fraction the way it is, change division into multiplication, and then flip the second fraction. So that becomes 1/2. That becomes 1 and 1. And there's the answer, 1/2. All right, now 17, this is just another way to show division, top divided by bottom. Just think of it that way, top 16, -16, divided by the bottom, -1. So -16 divided by -1 is going to be +16. And then on number 18, 15 doesn't divide by 45 nicely. So what we want to do for this one is I would just treat it like a fraction, like simplifying a fraction into lowest terms. And since we have one negative in there, doesn't really matter where we put the negative. It can be in the top, the bottom, but let's just divide the top and the bottom by 3. Or not by 3. Let's do by 5. That's a better number. 3 would work, but 5 is better. So 15 divided by 5 is 3. And that's where I was getting the 3 from. And then 45 divided by 5 is 9. And then you'll notice that can still be reduced by 3. So we're going to write -1/3. That's it for that one. All right, now this one has a mixture of addition. It's got division in it, got multiplication. So when multiplication and division are in it at the same time, just go from left to right. So let's do that. Let's just do that part first. And that's all I'm going to worry about first. Let's just do that. So we got -21 divided by 3 is -7. So I'm going to drop down the plus, and then -7 times 5. Okay. Remember, every time you do a problem with order of operations is involved, every time you do a step, the problem changes, right? It's a new problem altogether. So now we have -7, we have addition, and then we have multiplication. So we're going to take care of that multiplication first. So we're going to do that first. And it's going to go -7, just drop that down. And then -7 times 5 is -35. -35. So you got -7 plus -35. Now this is just basic addition, right? We're not talking about multiplication here or division. So the rule is when you have same signs with addition or subtraction, you keep the sign. You keep the sign. So that's going to be -42. So -42 for that one. All right, and then for number 22, we have to multiply before we add. Let's do cross canceling here. So that turns into the 7 and 14 could be both divided by 7. So 1 and 2. 14 divided by 2, or 14 divided by 7 is 2. 7 divided by 7. And then these can divide by 2. 2 divided by 2 is 1. And 6 divided by 2 is 3. So I'm going to work that out. And so when we do that, we get -2 thirds plus 1/6. So -2 thirds plus 1/6. And then you want to find the LCD. The LCD is 6, and 3 times 2 is 6. So we're going to do -2 times 2, which is -4. And then that one's unchanged. And then -4 plus 1 is -3. And then leave the denominator the way it is. So you just do 6, and then that can reduce to -1/2. Okay, so English, yeah, just looking at word problems here. Again, just kind of translating these from words into kind of understanding what the math is in the particular problem. So just kind of things to look at for this one is, like, if you see the word quotient, that is telling you to divide, right? If you see the word product, that is telling you to multiply. If you see the word, I don't know, like, I'm just kind of looking at the examples here. Twice. Now that's a very specific type of multiplication. That means you're going to multiply by 2. Or thrice. Nobody talks like that, but that might mean multiply by 3. See something like that. And then half could mean a couple different things that basically do the same thing. And here's what half could mean. Half, some people think of half as being like divided by 2. Or you can also think of it as multiply by 1/2. Because both things, like if you do something easy, 8 divided by 2, 8 divided by 2 is 4, right? And since division by 2 is the same thing as multiplying by 1/2, we can do that. Well, 8 times 1 is 8, and 1 times 2 is 2, and then 8 divided by 2 is 4. See, comes out the same thing, same way. So for number 23, the quotient of 9 and -3. So that means division. And then when it comes to division and the way it's worded, pay attention to that, because the way it's worded is telling you exactly the way you want to order the problem. So for this one, we want to do quotient of 9 divided by -3. Because 9 is mentioned first and -3 is mentioned second. So this means 9 divided by -3. 9 top divided by the bottom. Top divided by the bottom, which is -3. Now product, that means multiplication, and is a good indicator that we have parentheses or some type of grouping that needs to be involved here. So it says the product of -8. So you have -8, and then multiplied by the sum of 11 and -2. So I'm going to do this. I'm going to do -2 plus 11. Right? You can do 11 plus -2 as well in parentheses, but order doesn't matter when you're adding. Now let's work this out. So -2 and 11 makes 9. So now it's a new problem. -8 times 9. And then -8 times 9 is -72. All right, twice the difference of -4 and 8. Now it's got and in it as well, so we have parentheses, and then twice means multiply by 2. So that's what we're going to do. So we're going to multiply by 2. The difference, that means subtraction or minus. So you're going to do -14 minus 8, like that, or -8 minus -14. And so in that case, -14 minus 8 that makes negative 22. So you're going to have 2 times negative 22. And then we have a positive times a negative, which makes a negative. So negative 44. Negative 44. Half of the sum of 16 and negative 42. I'll show you both these ways. We can write that as 1/2, and then this says and. So I'm going to do negative 42 plus 16, like that. So if we take care of the parentheses first, so you got that, you got negative 42 plus 16. That is going to be, what is that going to be, 26? So I'm going to rewrite the problem. So now we have negative 1/2 times negative 26. And then 1/2 times negative 26 is negative 13. Negative 13. And the other way to do this would have been pretty much kind of the same thing. I mean, we are doing the same thing arithmetically. We're going to do negative 42 plus 16, and then just divide all that by 2, which is essentially the same answer, it's the same thing. So negative 42 plus 16, we already know is negative 26. And negative 6 divided by 2 is negative 13. Same result. Okay, that does it for 1.6. I'll stop the video here.